Hey everyone, today we are going to talk about one of the most commonly used concepts in software engineering, something you will find everywhere from your browser to large scale backend systems. The topic is cache. By the end of this video, you will know exactly what cache is, how it works, and how it is used in real production systems. Let's start with a simple real world example. Imagine you walk to a coffee shop every single morning. The shop is far away, so every day you spend time and energy making that trip. Now, what if instead you just brew coffee at home? It's always ready, always nearby. No trip needed, much faster. Cache works exactly the same way. Instead of fetching the same data from a database every single time a request comes in, cache keeps that data close by so it can be served instantly. Let's get a bit more technical now. Cache is a temporary, fast access storage layer. When data is requested repeatedly, fetching it every time from the original source, like a database or an external API, is slow and expensive. Cache sits in between. It stores a copy of that data so future requests can be served almost instantly. Three key properties to remember. Cache is fast because it lives in memory. It is temporary because data expires via a TTL, and it is intermediate, sitting between your application and the data source. So, how does cache actually work? Let me walk you through the flow. A user makes a request. The system first checks the cache. If the data is found there, that is called a cache hit. The response is returned immediately, fast, cheap, and efficient. If the data is not in the cache, that is called a cache miss. The system then goes to the database, fetches the data, stores it in the cache for next time, and returns a response. So the first request is slow, but every request after that is fast. Let's put cache hit and cache miss side by side. A cache hit means that the data was found in cache, no database call needed, response time is around 1 millisecond, server load is minimal, the user gets a fast experience. A cache miss means the data was not there. A database call is required, response time jumps to 100 milliseconds or more. Server load is higher. In a well-designed system, you want your cache hit ratio to stay above 90%. That means 9 out of 10 requests are being served directly from cache without touching the database at all. Cache doesn't just exist in one place, it shows up at multiple layers in a system. Browser cache. When you visit a website, your browser saves images, CSS, and JavaScript files locally. Next time you visit, the page loads much faster. Application cache. On the backend, tools like Redis or Memcache are used to cache things like user sessions, API responses, and frequently accessed records. Database cache. Databases like MySQL and PostgreSQL internally caches the result of frequently run queries. CDN cache. Content delivery networks store static files like images and videos on servers geographically closer to the user, so they load faster regardless of where you are in the world. Cache cannot store data forever. If it did, users would keep getting old, outdated data that would cause serious bugs. This is where TTL, time to live, comes in. TTL defines how long a cached item stays valid. Once it expires, the system automatically goes back to the source and fetches fresh data. For example, in Redis, you would write set user 101 lx ex 600, which means store this data and expire it after 600 seconds or 10 minutes. Short TTL means fresher data but more database load. Long TTL means less load but potentially stale data. Finding the right balance is part of good system design. There is a famous quote in computer science: there are only two hard things, naming things and cache invalidation. Cache invalidation means When the original data changes in the database, how do you make sure the cache reflects that change? If the cache is not updated, users will keep getting old data, that is called stale data, and it can cause real problems in production. There are a few strategies to handle this. TTL, just let the data expire on its own. Write through, whenever you update the database, you update the cache at the same time. Event driven, trigger a cache clear whenever a specific change happens, or manual invalidation, force clear the cache when needed. Each approach has trade offs. There is no single perfect solution, it always depends on your system's requirements. Let's talk about the most popular caching tool which is often used in production, Redis. Redis is an in memory key value store. It is incredibly fast. Responses come back in under a millisecond. It supports TTL natively and it is used by companies like Twitter, GitHub, Stack Overflow at massive scale. The commands are simple: set to store a value with an expiry, get to retrieve it, del to delete it, TTL to check how much time is left before it expires. Let's quickly recap what we covered today. Cache is a fast, temporary storage layer that sits between your app and your data source. Cache hit means fast response, cache miss means the database gets hit. TTL controls how long cache data stays valid before expiring. Cache invalidation is one of the hardest real world problems in distributed systems. Redis is the most widely used caching tool in production today. If this video was helpful, please like it and subscribe to the channel. Drop your questions in the comments. I read every single one. Thank you so much for watching the video. I will keep coming up with such videos. See you in the next one.